The IKEA store is the first IKEA concept store in Asia that was completed in 2003. Linked by other shopping centers such as Ikang Power Center and The Curve, this building is located in Muara Damansara, Selangor. The building takes up a floor area of 75,000 meters square. It has a total number of 4 floors and 2 basements. The manufacturers and suppliers of the components of the industrialized building system include Zimbi Sdn Bhd, which is in charge of blockwork system, MFE Formwork Technology Sdn Bhd, in charge of formwork systems, Setia Precast Sdn Bhd for precast component systems, and UAC Steel Systems Sdn Bhd for steel frame systems. Chosen for its speed in construction as after molding and pre-stressing of the rebar, precast concrete columns can be assembled right on the site with minimal labor strength and costs. Sizes of the columns can be preset into various sizes that are needed. Used for all floors above basement 2, precast hollow core slabs are cost-effective, easily assembled and built, as well as having a low self-weight. Hence, they require fewer raw materials, have higher concrete strength and reduced thickness, are structurally efficient, and allow the possibility for reuse and recycle. Precast hollow core slabs are widely used due to its heavy weight capacity, exceptional fire resistance, lower self-weight, good acoustics and thermal insulation, cost-effective construction solution, design flexibility, and many more. The basement level of the IKEA store is made up of reinforced concrete flat slabs. Floor slabs are cast in situ with reinforced steel bars, which is known as rebars, as reinforcement and formwork, after which concrete was poured into the formwork and left to dry. Thanks to its ease of construction, reinforced concrete flat slabs are a popular choice in industrialized building systems. These slabs do not need grouting in order to combine them together. Reinforced concrete staircases that are used in the IKEA store are precast double flight staircases with a landing. The staircase was connected to the hollow core slab with a piece of cast in situ reinforced concrete flat slab casted at the edge of the stair flight. This type of staircase was chosen for IKEA as it requires little assembling time. Also due to its easy and fast assembly, precast steel roof truss was used for this building, as it is lightweight for transportation. Steel members of the roof truss were pre-made off-site, while the individual parts are bolted and welded on-site after transportation. The IBS construction method is done whereby the required components of a building to be reconstructed is manufactured or fabricated in a factory before being transported to the site to be assembled. The advantage of the IBS is that it speeds up the process of construction and at the same time it reduces the overall cost of the project. The building that we use to demonstrate the example of construction using IBS components is Rose Bay Apartments, located in Sydney, Australia. This building uses the traditional method of building construction. We have modified this building in order to show the construction of this building using prefabricated concrete components. For the manufacturing and prefabrication of the precast components, detailed drawings of these components are done in the drawing office. Once completed, the drawings are then sent to the factory to create precast concrete panels. These panels are then sent to the construction site using trucks. For the foundation of the apartment, the IBS construction begins by laying out two layers of masonry bricks along the layout of the load-bearing walls. Once all the masonry bricks are laid out, the hollow core floor slabs are placed on these bricks to create the ground floor of the building. After all the slabs have been laid out, gaps between these floor slabs are closed using a layer of cement which serves as an adhesive to help prevent leakages. After the floor slabs are completed, precast columns are installed, which is then followed by the precast walls using a crane. The columns are then set up piece by piece. Once completed, the walls are placed in between them. Cement is then used to fill up the gaps between the columns and the walls for the load-bearing walls. Concrete of grade 35 with the ratio of 1:3:5 is used. Once all the walls and columns are installed, the beams are then placed on the walls and columns to provide support for the weight acting ground floor. Staircases are made of precast concrete in the factory before they are transported to the site for installation. Once the walls and floor structures are assembled, the precast stairs are lifted with a crane to be installed in a slot specially prepared for the staircase. The staircases are also strengthened using rebars. For the upper floor construction, hollow core floor panels are placed on the beams and walls of the lower floor, and the process is repeated all the way to the top floor. Hence, through the IBS construction method, construction is fast and smooth with little issue. For the roof, steel trusses are also prefabricated in the factory before being transported to site for installation. These steel structures are installed on the top floor of the building before the purlins are added to them. After that, the galvanized steel roof is added on top of the trusses and purlins, thus completing the construction of the building. Embodied energy is the energy consumed by all of the processes associated with the production of a building. In this calculation, taking table 1 as an example, we have 3 different sizes of concrete slabs in our project. Here, we are using concrete hollow core slabs. Thus, we have to minus out the area and volume of the cylinder, which is the hollow core, to calculate their embodied energy. Total area and volume are calculated according to the number of each type of slabs. Density of concrete slab is taken from the lecture slide and from the reference book. Thus, mass of concrete slab can be calculated by the following formula. According to the references, energy coefficient is a constant. Thus, embodied energy is calculated by the following formula.